To start this topic off, we're just going to look at the alternative way of measuring angles, and that is radians rather than degrees. And the reason radians becomes important is for later on when we're doing calculus and trig functions, because we really need to use radians as the angle measure for the calculus to work. So we need to know what radians are. The conversion, I always think of it this way. I mean, it's 180 degrees is pi radians, but in my head I always think 360 degrees is 2 pi radians, because I can associate that better. 360 degrees being a complete circle, and of course the circumference of a circle is 2 pi r, so I can associate 2 pi with 360 quite easily. That's why I tend to remember it that way. We're going to see some common ones come up a lot, basically because of our exact values of 30 degrees, 60 degrees and so on. So the radian conversions for those, here we go, let's just go through them. 30 degrees becomes pi on 6, because remember pi is actually 180, so 180 divided by 6. 45 becomes pi on 4, 60 is pi on 3, and 90 pi on 2. So these are the sorts of ones we will see popping up a lot in questions. Then we go into the second quadrant and we get 120, 135, 150 and 180. Third quadrant brings us to 210, 225, 240, 270, and we get round to the fourth quadrant, 300, 315, 330, and finally we get the 360. So they're all the ones we saw with the exact values in degrees, you know, root 3 on 2, 1 on root 2, all those sorts of things, and we'll see them now with radians as well. So we get a simple little question like this, because obviously not everything's an exact value. 67 degrees, and we've got to express it in radians. Well, we just simply multiply by pi over 180. Because effectively, if you think of it, you're multiplying by 1 sort of. I mean, pi is not 180. Pi is still 3.14159 and so on. But if you think pi is 180 degrees, pi on 180, it's sort of like thinking of it as 1. You're multiplying by 1. So 67 pi on 180 radians would be the exact value. We tend to approximate a lot with the radian measure. So to 4 decimal places, I've done mine, 1.1693. What it illustrates is the size of a radian. 1 radian, or 1.1 radian, is 67 degrees. So a radian is actually quite large of a circular measure. 36 degrees. Okay, well that'll be 36 pi on 180. In this case, that simplifies down and we get pi on 5. Well, if we're going the other way around, now we want to get rid of the pi out of the answer. You see, you can think of it that way. So pi on 8, now we'll multiply it by 180 on pi, because we're going the other way around. The pi's cancel, and I get 22.5 degrees. Of course, you don't have to have pi in the radians, you can have a number. But you still multiply that by 180 over pi. Remember, pi, you're using the number 3.14, etc., etc. And that's actually, wow. Again, illustrating how big a radian is. 111 radians actually comes out to be 6,365.6 degrees. They are quite large. Okay, that's all we'll do to start off with today. 11G, which actually carries on, I think, from the exercise or the chapter we were working on at the end of last term. But so 11G now takes it into the trig ideas.